flags and control flags, 6 conditional flags and 3 control flags. So the conditional flags are carry flag and parity flag and auxiliary carry flag and a zero flag and sign flag and overflow flag. So control flags are namely draft flag and interrupt flag and directional flag, and the carry flag and the parity flag. So these 6 conditional flags are affected by the arithmetical operation of the microprocessor. So this is the entire operation of the flag register. So the sign flag, this flag said when the result of the computation is negative. So zero flag, this flag is said the result of the computation or comparison performed with the instruction is 0. So the 0 flags will be set. The parity flag, so when the parity flag is set to 1, the lower bit of result contains even number of 1s, the odd number of 1s set to 0. So the carry flag is set when there is a carry out of the MSB in case of addition of borrow, in case of subtraction. So what is the auxiliary carry flag? This will be set that there is a carry from the lowest nibble. So bit area of during addition and a bar of the lowest nibble. So and bit during subtraction. So and overflow flag and trap flag and directional flag, interflag. These are the control flags. These control the certain operation of the microprocessor. So these are 8086 register banks. So general purpose register, there are 4 16-bit general purpose registers, 2 pointer registers, 2 index registers, 1 instruction pointer, and 4 segment register, and 1 program status word. A flag register otherwise called as a program status word. So there are 14 16 bits available in 8086. Okay, the index registers are source index and destination index register. Segment registers are CS means code segment, DES means data segment, SS means stack segment, ES means extra segment. So these are register special functions. These are table indicates the registers and with the special functions. So AX indicates accumulator. The source of 16-bit registers arithmetic and logic operations. And CX is a count register, is used to hold the count value and shift, rotate, and loop operations. So DX, a data register, is to hold the data of multiplication and division operation, and SP is a stack pointer, is to hold the offset address of the top stack memory, and BB is the base pointer, is to hold the base value of base addressing using stack segment register to access the data from the stack memory. So source index is to hold the index value of source operand for the string instruction. Data index used to the hold index value of destination operand for the string operation. So the bus interface main components are instruction queue and segments and register and instruction pointer. So instruction queue is in instruction queue it supports the parallel processing. So when execution unit is busy in decoding and executing current instruction, the buses 8086 may not be in use. So at that time, the bus interface unit can use the buses to fetch up to 6 instruction bytes for the following instruction. So BAU stores these prefetched bytes in the FIFO registers called as instruction queue. So when execution unit ready for the next instruction, it simply reads the instruction from the instruction queue instead of memory. So pipelining. So execution unit of 8086 does not have to wait in between for the bus interface unit to fetch the instruction byte from the memory. So the presence of the queue in 8086 speed of the processing, so fetching the instructions while the current instruction executes is called as a pipelining. So memory segmentation. So 8086 has a 20-bit address bus. It can address maximum of 1 MB memory. 8086 can work with only 64 segments at the time within the 1 MB range. This is a 4 memory segments called as a code segment and stack segment and data segment and extra segment. So this is a segments memory diagram for the 4 segments. The 4 segment forms a 64 memory segment. The code segment is that part of memory where the bus interface unit is currently fetching in section the code bytes. Stack segment. Section of the memory is reserved to store the addresses and data while subprogram executes. So the used for storing the data values to be used in the program. Segment register. First, hold the upper 16 bit of starting address of each segment. The 4 segment registers are CS means code segment register, DS means data segment register, SS means stack segment register, and ES means extra segment registers. This is a segments memory configuration for the each segment registers, base segment registers. Okay, the address segments of 20 bits. A segment register stores only up to 16 bits. The BOE always inserts 0 for the lowest bits of 20-bit address first of the starting address. If CS is 3480, the code segment will start 3480 appends the 0 at end. The 64 segment can be located anywhere of memory. Will start at address with 0's at lowest bits. So instruction point register. A 16-bit register holds a 16-bit offset of the next instruction byte in the code segment. The bus interface unit uses the instruction pointer and the code segment register to generate the 20-bit address of the instruction to be fetched from the memory. So this is how to calculate the physical address for the memory location. Code segment starting address plus instruction pointer. Then add two values, we will get the physical address of the each instruction. Stack segment stack pointer. Upper 16-bit starting address of stack segment is stored in the stack segment register. It is located in the bus interface unit. So a stack pointer register holds a 16-bit offset from the starting of the stack segment to the top of the stack. It is located in the execution unit. So other point index register. So base point register and a source index register and a distance index register, and can be used for the temporary storage of data. The main used to hold the 16-bit offset of the data. So add in one of the segments. Thank you. That's all about the architecture of 8086.